We're going to convert from rectangular equations to polar equations. So just a few reminders. The formulas you're going to have to memorize is that x squared plus y squared equals r squared. You could also write it as this. Also, x is equal to r cosine theta, and y is equal to r sine theta. These are some things that you just have to keep in mind for this lesson. So if I'm going to convert from rectangular equations, rectangular means you're using x's and y's. Polar means you're using radiuses and thetas, okay? So I don't want any x's or y's once I convert it into polar. So I'm going to use these formulas up here. I know y can be replaced with r sine theta. So I'm going to put r sine theta in the place of y, 1/2. Instead of an x, I can put r cosine theta. Now I'm going to square this whole thing. Since I have a squared out here, this will be r squared cosine squared. I still have the 1/2. I have r sine theta. So your goal, the goal whenever you're converting to polar is have the radius by itself. Okay, so let's try to get the radius by itself. I am going to, I think a good idea would be to divide by r cosine squared theta on both sides, so that cosine squared will cancel out. Radius will cancel out with just one of the radiuses, so it's no longer squared. And then on this side, the r's would cancel out. So here's what I'm left with. I have sine theta divided by cosine squared theta equals 1/2 r. And what's my final step to get r by itself? Thank you. Multiply by 2 on both sides. So I'll just put a 2 there. Okay, and guys, I never want to end with fractions, so I'm going to change this up a little bit. What are some ideas that you have? How do I not get fractions? Not cotangent. You're close. You're on the right thinking track. Perfect. Tangent and secant. This right here is tangent. So this is 2 tangent theta. And 1 over cosine is secant theta. There you go. It is now in polar. Notice we have no more x's and y's. All we have are r and thetas. All we have is r and thetas. You can always graph this. This we know how to graph. This is just going to look something like that. If you were to put this into the calculator, you'll also get the same graph. So you should be able to graph one or the other. I don't know what this looks like just looking at it, but if I turned it into rectangular, I would be able to graph it, and vice versa. So you'll see along as we go along the lesson that sometimes you'll be able to graph it easier when it's in polar form versus when it's in rectangular form. So in this case, it was easier to graph when it was in rectangular form. Okay, here's the next one. We're going to convert this to polar. So I'll put, for x, I'll put r cosine theta. It's still squared. And for y, I'll put r sine theta. And this, if I square it, will be 4r squared cosine squared theta, r sine theta equals 1. And I'll just combine my r's. This is r squared and another r, so this is 4r cubed cosine squared theta, sine theta. That's good. We divided by 4. What else should we do to get r by itself? Okay, I'll just divide by 4 then. So I have r cubed cosine squared theta sine theta equals 1/4. Good. So you were supposed to just divide by cosine squared theta and sine theta. Those cancel. And same thing, it comes over here. Cosine squared theta, sine theta. And we just don't want fractions. So what did you guys put? What's 1 over cosine squared? Secant squared. And what's 1 over sine? Cosecant. And if you want to get rid of the 3, what can you do? Yep, you could cube root it to just make it a plain r instead of an r cubed. And that's it. All right, next one. Now we're going to convert from polar to rectangular. Guys, what does this mean? Okay, so what kind of graph do we have? A circle, because it says the radius is 4. So you're going to have a radius of 4. 1, 2, 3, 4. It's going to look like this. Okay, so let's go ahead and convert it to rectangular. That means we want x's and y's instead of r's and thetas. Okay, so what can we replace r with? Yep, square root of x squared plus y squared. And if you want to get rid of this square root symbol, just square both sides. So you have x squared plus y squared equals 16. All right, guys, remember this formula? This is the equation for a circle. This right here is a circle centered at 0, 0 with the radius. If this is the equation for a circle, what is your radius? 4, because the equation says it's squared. Okay, so the square root of 16 is 4. So that's what your radius is. All right. And also, just FYI, you can also see it like this, some number squared plus y and then some number squared equals r squared. This is where your center is. That's where your center is. Okay. Let's try this one. So whenever you have theta, when you have an angle, when you go to rectangular, it'll just be a line. So when you go from theta, an angle, to rectangular, it'll be a line. So if you think about your unit circle, I'll call this x and I'll call this y. An angle with this measurement is right here. This is the measurement of theta. And the coordinate right here, you guys remember what it is? May, what's the x coordinate of that point? Negative. Perfect. Okay. Paige, what's the y value? Negative? Y positive. Yep. Very good. You got it. Okay, so let me remind you guys, if this is going to become a line, I'm going to remind you of how to get the slope. So this is how you get the slope. You have your other point at the origin. So the change of y is just square root of 3 over 2. And the change of x is negative 1/2. And if you simplify this, you'll get negative square root of 3. So that means my equation is, this is my slope. X, remember it's mx plus b. And your b value is just 0, your y-intercept. So this is your equation. So far, guys, we have been able to graph every single one of these. If you can't graph it in this form, because that looks a little crazy, you can definitely graph it in this form. So if you wanted to solve for y, you'd get y equals 1 over 4x squared. You can graph this. You can easily plug in numbers and graph that, okay? All right, so Let's go here. We're going to convert from polar to rectangular. Do you have any ideas what we can do first? I'll take all suggestions. Good, that's a good suggestion. What are some other ones? To what? Good, that's another good suggestion. Okay, I'll do that one. So r equals 2, I'll change cosecant to 1 over sine theta. So I can make it look like this. Okay, what's another suggestion? Good. I'll take your suggestion. I'm going to multiply by sine theta on both sides. That cancels. So I'm left with r sine theta equals 1. Now what can I do? What is this? Oh, sorry, that's a 2. Thank you. Yep, y equals 2. Can you guys graph that? What is it? What kind of line? A horizontal line. Good. Okay, so this was just a horizontal line. You guys should be able to graph each one of these. So this is the y-axis at 2. I'm going to draw a line through it. So that's what that graph looks like. If you were to type this into your graphing calculator, it would give you the same thing. But if looking at this, I don't know how to graph that. But I can definitely graph it when it's in rectangular form. Okay? All right, next one. I'll take your suggestions. These are the three. X squared plus y squared is r squared. X is r cosine theta. Y equals r sine theta. Okay, I rejected this solution. These are the only two left. So what should I do? Who said that? Did you say that, Cruz? What'd you say? Good, I'll take that. I'm going to put an r on both sides. So I'm going to have r squared equals 6r cosine theta. Oh, and Brooklyn, I'll take your suggestion too. Sorry. I'm going to change this r squared. Now that it's an r squared, I'm going to change it to x squared plus y squared. So this is what I have. And of course, r cosine theta, that's this right here. I'll replace that with an x. Okay, now we're here. I don't know what you guys saw in your previous classes. Maybe you've seen this method. I'm not sure, but I'll show you. I'm going to try to get this to look like an equation of a circle. An equation of the circle, here's just an example. This is an example of equation of a circle. It's centered at 0, 0 with a radius of 4. I want to get into this type of format, but I have a 6x here. So I'm going to move it. I'm going to have x squared. I'm going to move the 6x, so it's a minus 6x. Put some space, equals 0. Write it like that. All I did, guys, was just move that to the other side. That's all I did. Okay, now here's the math trick. I'm going to add 9 to both sides. Let me explain the logic right there. If I have 1 equals 1 and I just add 9 to this side, this is no longer true. I also have to do it to this side. Now this is still a true statement, even though I put 9s in. Is that okay, guys? Okay, let me show you why I did that. I wanted to create a perfect square. If I factor this, two numbers that multiply to 9, but add to -6 are -3 and -3. So I can write this as x minus 3 squared, and then the rest of your equation plus y squared equals 0 plus 9 is 9. And I can stop there. This is a circle centered at 3, 0 with a radius of 3. So the center is at 3, 0, and your radius is 3. It's a circle. And if I drew this, it'll be right here, centered at 3, 0, with a radius of 3. So it looks something like that. It's always opposite. So if it's a -3, it's centered at +3. I think this trick is called completing the square. Okay, and the way that you can come up with what number to add to both sides, take half of this and square it. So half of 6 is 3, square it, you get 9. That's how you come up with what to add. Okay, so for example, let's say I had x squared plus 10x plus y squared equals 7. Okay, and I want to complete the square. Half of 10 is 5, square it is 25. So now when I factor this, make sure you add 25 to that side. You have to do it to both sides. If you were to factor this part, two numbers that multiply to 25 but add to 10 are 5 and 5. So this is x plus 5 squared. And that gives you your circle equation. All right, next one. We're going to convert this circle to polar form. And remember, guys, you should be able to graph each of these problems, whether it be in this format or in the polar format. This one, this is a circle. Jacob, where is it centered? Yep, 32. What's my radius? You're very close. Remember, this is a formula. R squared is 13. So what's just regular R? You got it. So guys, that's the information I have. I can graph that. The center is at 3, 2, and the square root of 13 is approximately 3.6. So I can go about out here. 1, 2, 3, a little bit past it. 1, 2, 3, a little bit past it. This is what my graph should look like. Okay, now let's change it to polar. Any suggestions? All right, Carter, what was your idea? What'd you do?
Put everything like factored out the x minus 3 squared.
Oh, like expand it? Yeah. Okay, good. So you did x minus 3 times x minus 3 plus y minus 2 times y minus 2 equals 13. And you multiplied it out? Okay. So you'll get x squared minus 6x plus 9. And for this one, you'll get y squared minus 4y plus 4 equals 13. Yes? Okay. What y'all do next? Oh, okay. I see. So 9 and 4 is 13, and you subtracted it to the other side. So it just kind of canceled out and gave you 0. Good. Okay. Let me not skip steps for everyone. Okay. So I'm going to put these two together. X squared plus y squared minus 6x minus 4y plus 9 and 4 is 13 equals 13. Those cancel. All right, Cruz, what'd you do next?
You change the x squared plus y squared to y squared.
Perfect. Thank you. Any other ideas? Ibrahim, what'd you do? Okay, so you basically put these on opposite sides. Okay, good idea. I'll move these over. Yeah, I just didn't want negatives. So you have r squared equals 6x plus 4y. Good,
Substitute r sine and r cosine for x and y.
perfect. So we have x equals r cosine theta, that's one of them. Y equals r sine theta. We're gonna replace those. So I'm gonna write this as r squared equals 6 r cosine theta plus 4 r sine theta. Dylan, what'd you do next?
Pull the r.
Good, pull out the r's. So r squared equals, Brooklyn, you see how these both have r's? I'm gonna pull them out. This is 6 cosine theta plus 4 sine theta. Divide by r. Divide by r. Divide by r. Those are gone. R squared over r is just r. So my final answer is r equals 6 cosine theta plus 4 sine theta. Wonderful.